Now we are going to be entering a very new topic which is known as trigonometry. Trigonometry is it's a branch of mathematics, or say part of mathematics, that has to do with the properties of triangles. We're talking about the features of triangles. What does triangles contain? Gives us a full understanding of triangles. So before we start going into that, we need to understand, okay, what are the different types of triangles? Like we have the equilateral triangle. We have the equilateral triangle. Now in this triangle, you observe that all sides are equal, all angles are equal. So equilateral triangle. It's equilateral triangle. So you see all sides are equal, all angles are equal. Then we have another type of triangle which is known as the isosceles triangle. The isosceles triangle, you have that two sides. This one you have three sides / three angles are equal. While for the isosceles triangle, what you have here is two base angles, or two angles are equal, and two sides equal. So that's for the isosceles triangle. Then another type of triangle is known as the scalene. We call it the scalene triangle. Scalene triangle. No sides or no angle. No side / angle are equal. So you have the isosceles, you have the equilateral, you have the scalene, then you have the right angle triangle. So the right angle triangle now works at angle 90, and right angle triangle. Now this right angle triangle is what actually follow a theory which we are going to talk about later on. So take note of these three types of triangle. We have the equilateral triangle, we have the isosceles triangle, we have the right angle triangle, and we have the scalene triangle. We have the equilateral triangle, we have the isosceles triangle, we have the scalene triangle, and we have the right angle triangle. Now take note of these points right away. So we have the equilateral triangle, we have the isosceles triangle, we have the scalene triangle, and we have the right angle triangle. So draw this triangle. This is a triangle now. You see this triangle now? This is an equilateral triangle, right? This is an equilateral triangle. So let's assume we've not drawn this line yet. Let's leave this line aside first. So now this is an equilateral triangle, and make sure all sides are labeled 2 centimeters each. Now we've labeled all of them 2 centimeters each. So now I'm saying now that let's clean this away. Let's clean this 2 centimeters away, and just divide this equilateral triangle into 2. So when we divide it into 2, what happens? Here is 1 and here is 2. Then we have this right angle here. Now take note of this diagram. Now in a triangle, all angles are equal to, the sum of all the angles in a triangle is equal to 180 degrees. So since an equilateral triangle, it implies that this side is 60 degrees. Now since an equilateral triangle, if we are dividing it into 2, it implies that here is 30 degrees. So we have 60 degrees, we have 30 degrees. Now here we don't know what here is, so let's call here x. That's the first thing. So now we have already drawn this triangle. Now what I want you to do is, let's clean this other part of the triangle now. Let's say we are not focused on this other part of the triangle. Let's focus our attention on this right angle triangle. So this angle now has not changed. This triangle has not changed from equilateral triangle to right angle triangle. So focus your attention on this now. Now I'm going to say that using our knowledge, because there is a rule known as Pythagoras theorem. Pythagoras theorem, what does the rule state? The rule states that the sum, that's the square, states that the square of hypotenuse is equal to square of opposite. Square of opposite plus square of adjacent. Now, Pythagoras theorem states that the square of the hypotenuse is equal to the square of the opposite plus the square of the hypotenuse. So we have the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. Now, take note. What is an hypotenuse? Some persons will say the hypotenuse is the shortest side, but I will tell you the hypotenuse is the longest side. So you see this triangle now. The place that is facing this right angle is known as the hypotenuse. That is the hypotenuse. Then, for example, this is angle theta. We call it theta. Angle theta. The angle that is facing theta is known as the opposite, while the angle that is not facing theta is known as the adjacent. So we have the angle that is facing the right angle is known as the hypotenuse. The angle facing theta is known as the opposite, while the angle not facing theta is known as the adjacent. So that's the first thing. Take note of this. So the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. So before I start proving some important things to you, just take note that we have something called SOHCAHTOA. We have something called the SOHCAHTOA. And what does SOHCAHTOA represent? SOHCAHTOA says sin theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. Tan theta is equal to opposite over adjacent. So take note, we have the first one, sin theta, which is opposite over hypotenuse, cos theta, which is adjacent over hypotenuse, then we have tan theta, which is opposite over adjacent. So take note of this valuable point right away. So sin theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent. Now we also have another part. We have the cosec theta. Cosec theta, which is equal to 1 over sin theta. And what is sin theta? 1 over sin theta. 1 over sin theta is hypotenuse over opposite. Sec theta, which is 1 over cos theta. 1 over cos theta is equal to hypotenuse over adjacent. Then we have cot theta, which is equal to 1 over tan theta, which is equal to adjacent over opposite. So you have the opposite. There's a form of switch. So note that sin theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, tan theta is equal to opposite over adjacent, cosec theta is equal to 1 over sin theta, sec theta is equal to 1 over cos theta, cot theta is equal to 1 over tan theta. Take note of this valuable point. So we are going to the next part, which is known as special angles. We have special angles. So there are some angles known as special angles. Special angles. But before we go into the special angles aspect, we have to come back to this triangle to analyze our knowledge of Pythagoras theorem. So using Pythagoras theorem, this is our hypotenuse now. This is our hypotenuse. So it means that the square of the hypotenuse, 2 square is equal to the square of the adjacent plus the square of the opposite, which is x squared. So that means 4. What's 2 squared? 4. 4 is equal to 1, because 1 squared is 1 plus x squared. Take 1 to the other side. We have 4 minus 1 equal to what? X squared. It therefore implies that 3 is equal to x squared. Therefore, x is equal to square root of 3. X is equal to square root of 3. So take note of this valuable point. Now, if x is equal to square root of 3, the next step is to analyze the questions critically. So meaning that we are going to remove this x now and just write x equal to root 3. Now take note, in this part here, we did not say go and check calculator for root 3. We said let's leave it as root 3. Take note, we did not say go and check calculator for what root 3 is. We said leave it as what? Root 3. So now we have already solved this. The next step is we are going to find special angles. So we have sin 30. Let's work with sin 30. Remember, sin is opposite over hypotenuse. This is 30. Opposite to 30 is what? Sine 30, opposite over hypotenuse. So let's write opposite over hypotenuse, which is opposite is 1, hypotenuse is 2. So if you manage to go to your calculator to go and check what sine 30 is, sine 30 will give you 0.5. And what's 0.5? 1 over 2. So sine 30 degrees is 1 over 2. We have cos 30 degrees. Cos 30 degrees. Cos means adjacent over hypotenuse. Adjacent is root 3. So adjacent over hypotenuse, which is root 3, hypotenuse is 2. So we have cos 30 is root 3 over 2. Then we have the next part, tan 30, opposite over adjacent. Now what's opposite? Opposite is 1 over adjacent is root 3. Now if you remember very well, we've actually made a video on a very great topic known as SOD. And under SOD, I talked about rationalization. And I said, you cannot have root 3 under. You cannot have any root under. You have to rationalize it in a way that this root 3 is no longer appearing there. So meaning that you have to rationalize it by the conjugate, or rationalize it by another root, by the same root. So in this case, you are going to multiply this by root 3 and multiply this by root 3. You multiply the numerator by root 3, you multiply the denominator by root 3. 1 times root 3 will give us root 3. Like I said in SOD, root A times root A is equal to A. The square root will leave because we are having the same letters inside, or the same numbers. The square root will leave. So root 3 times root 3 will give us what? 3. So that means our answer to tan 30 degrees is root 3 over 3. Our answer to cos 30 degrees is root 3 over 2. Our answer for sin 30 degrees is 1 over 2. That's the first part. Then we also have sin 60, cos 60, and tan 60. So we are going to work with this right away. So for sin 60 degrees, we have that sin 60 opposite over hypotenuse. Sin 60, the opposite is root 3, then hypotenuse is what? 2. You see that there's a form of switch now. So that means cos 30 is equal to sin 60. Sin 30 will definitely be equal to cos 60. So let's check cos 60. Cos 60 degrees to be equal to adjacent over hypotenuse. Adjacent is 1 over 2. Hypotenuse is 2. You see? Cos 30 is equal to sin 60. Sin 60 is cos 60 is equal to sin 30. You see the switch? So you are just trying to say this is this. Then this will definitely be this. You see the similarity. Then now we have tan 30 degrees. Tan 30 degrees. Tan 60 degrees, I mean to say. Tan 60 degrees. Tan is opposite over adjacent. That is root 3 over 1, which is root 3. So tan 60 is root 3. That's the first thing. You have the special angles where you have sin 60 is what? Root 3 over 2. Cos 60 is 1 over 2. Tan 60 is root 3. Sin 30 is 1 over 2. Cos 30 is root 3 over 2. Tan 30 is root 3 over 3. Because we had to rationalize to ensure that we get the answers we need.